Hello everybody, let's talk about using the fundamental trigonometric identities, the ones we've reviewed before, our reciprocal identities, our Pythagorean identities, and our quotient identities. And in order to be able to use these for what we call verifying identities, before we even get there, we want to talk a little bit about this idea of just using the fundamental trigonometric identities at all. A lot of this is review, but I think we would stand to be able to use our six trigonometric, our fundamental identities to evaluate something like a trigonometric function. So let's go over it. Let's talk about this idea. Let's say that we're told that the cosecant of x is -5 and that cosine of x is less than 0. Is it possible to find all six of the trigonometric functions based on these identities? Well, most certainly we can say we know that sine of x, based on our identity over here for the reciprocal identity, is equal to -1/5. So right away, we already have an identity that we can use here. Any others? Well, cosine of x must be negative. We know that the cosine of x is related to sine of x by the Pythagorean identity. That is, the square of cosine plus the square of sine must equal 1. So, what could we say? In this case, let's make the substitution. The square of the cosine of x plus the square of -1/5 is going to equal +1. And so if we want to find this cosine squared x, subtract 1/25 from both sides. So we're going to subtract 1 minus 1/25, the square of 1/5, to get 1/24. Sorry, to get 24. Let's try that again here. Yeah. Getting our common denominators of 25, we've got 25 minus 1 over 25, which is to say 24/25. So if we isolate cosine of x to take away that square, normally we would say plus or minus, but we know that cosine of x must be less than 0, so that's going to be a negative value, and it'll be the square root of 24 over the square root of 25. 24 over the square root of 25. And we should reduce, of course. So our cosine of x value is going to be, let's see, square root of 24, you recall that's the same thing as the square root of 4 times 6. And so we can treat this as 2 square root of 6 divided by 5. And of course, that's a negative right here for that value. So there we go. There's 3 of our trigonometric functions, cosecant, sine, and cosine. We can now get secant of x very easily, right? Because secant of x is our reciprocal of the cosine of x. So using our identity right here, we could state that if we take our reciprocal, 5 over 2 square root of x, of 6, pardon me, rationalize the denominator by multiplying by square root of x, we actually get -5 square root of 6 divided by 12. And let's see if there's anything else. Well, certainly, right? Tangent and cotangent are directly found using our quotients. So for tangent of x, in this case, we can state that if we take -1/5 and divide it by our trigonometric cosine here, -2 square root of 6 over 5, and rewrite, we're going to find that we have a positive 1 over 2 square root of 6, and rationalizing the denominator would show us that it is the square root of 6 over 12. Consequently, cotangent of x happens to be the reciprocal of tangent of x, and I'm just going to take the reciprocal here directly. That's going to be 2 square root of 6. So there we go. 1, 2, 3, 4, 5. Any we miss right here? Cosines and 6. 6 trigonometric functions.